Hi, everybody. We are back continuing our discussion of the normal distribution. In the last segment, we talked about how to use the z-score to essentially transform any normal distribution into the standard normal distribution. And again, the standard normal distribution is a normal distribution that has a mean centered at 0 and a standard deviation equal to 1. What we're going to do in this segment is we're going to talk about how to utilize the standard normal table in order to help us calculate areas underneath that bell-shaped curve without having to use calculus. So what the table does for us is it actually gives us a cumulative probability in between 0, the middle of the distribution, up to some desired value for z, up to some positive value for z. Now, you'll notice z could be negative, right? If we were looking at this distribution, it's possible that we have negative values of z here. But since the distribution is symmetric, okay, we could just use a positive value of z that corresponds to the same negative value. So really the absolute value is really what's going to matter here. And what the table does for us is it's going to show us the area underneath that curve. So if we were interested in the probability that z was between 0 and 2 here, okay, then what we would do is we would go to the standard normal table, we would find the z value associated with 2, and the standard normal table reports to us this probability that corresponds to the area under the curve in between 0 and 2. Okay, so let me go ahead and show you a small example here of generally how to use the table, and then I'll show you the full one-sided table in just a moment, and we will do several examples. Okay, so if we wanted to know the probability that z was between 0 and 2, we're going to go ahead and take a look at our standard normal table, which you should have access to in one of the course material content folders. And it is known as a one-sided normal table, the one that we're going to be using specifically. And the rows of this table, okay, show the value of z to the first decimal point. Okay, the columns of the table give the value of z to the second decimal point. So if we wanted to go farther than 2 decimal points, we're going to be using a little bit of an approximation, but that's okay. This table is going to be fairly useful in that it won't require us to do any calculus, provided we know the z value up to 2 decimal places. Okay, so if we wanted to calculate the z value or the probability that z is between 0 and 2, we would go down to the row where the z-score is equal to 2.0, and then we go to the column where there is a 0 in the second decimal place, in the hundredths place. And you would note that in the table, that corresponds to 0.4772. And this is the probability that z, again, is between 0 and the desired value that we have plugged in using this table here. Okay? So what we're able to do now is you can come back to the picture. And again, I always recommend really drawing this picture. It's a good idea. And we can now use the table to go ahead and identify specifically this region. Okay, if we wanted to say compute the value that z was smaller than 2, okay, not between 0 and 2, but just z was any value lower than 2, then that means we would also want to include the area to the left half of the bell-shaped distribution as our relevant pink region in this situation. So if we were going to do that, we know the area between 0 and 2 is 0.4772 from using the table. But we also know by symmetry of the distribution, the area between 0 and negative infinity makes up half of the probability mass. So that area in green has to be equal to 0.5. And we would just add this to the area in pink that we had calculated using the standard normal table. Okay, and this would give us a result of 0.9772, 97.72%. Of the area underneath that curve is captured in both the green and the pink regions added together. Okay, now suppose we were asked to find the area between -2 and 0. Okay, well, remember, if the bell-shaped curve is symmetric, okay, then the probability that z is between -2 and 0 is going to be exactly the same as the probability that P was between +2 and 0. So we can use exactly the same one-sided table values, even if the Z values fall on the negative side, the left side of 0 here. So again, if we wanted to figure that out, all I would do is I'd plug in a +2 into my standard normal table, and I would look at the associated probability, and by symmetry, this also would have to be 0.4772. Okay, let's go through another example, and I will actually switch back to the bigger standard normal table so you can see how this is done. But the first question here is asking, what is the probability that Z falls between 0 and 1.22? Okay, how many Z values are we going to have to look up here? Well, we're just going to need one corresponding to this value 1.22. Okay, so let's go ahead, and I'm going to switch my screen share here for a moment to show you what that Z table looks like, and we're going to find the Z value of 1.22. We're going to go to the appropriate row and column to compute that probability. Okay, so here we are looking at our standard normal table. We want to go to this row here where we are looking at the row value of 1.22. Okay, and then, so our Z value is 1.22. That value up to just one decimal place is 1.2, but then we're going to come over to the appropriate column and find that second decimal value, which is equal to 0.2, or 0.02 rather. And we would go down and we would see here that that is associated with the area under the curve equal to 0.3888. So I'm going to jump back and we'll be able to answer the question. So note, once we've done that, we can see here that the correct value to be using is 0.3888, which is choice B. And that is the area between 0 and 1.22 in terms of the Z value, after we've already transformed the X data using the Z score here. Let's go ahead and take a look at another example. If we wanted to know what is the probability that Z is less than 1.5? Well, remember, the standard normal table tells us the probability that Z is between 0 and some value. So in this situation, we're going to have to exploit the symmetry of the distribution, recalling that, again, the left half of that distribution in green here, okay, is going to be 1/2 of the entire area under that distribution, which is equal to 0.5 right here. And now all we have to do is look up the table value for 1.5 in order to compute the area of this pink region. So again, let me switch my screen share here to the standard normal table so we can find that value. So note, we were looking for this value of 1.50. So I go down to the row associated with 1.5. And then we're going to go to the column associated with a 0 in the second decimal place. And that'll tell us that we are looking at the area corresponding to 0.4332. That is the value of the area between 0 and 1.5. Okay, so let's go back to the question, and now we can answer it. So we computed the area between 0 and 1.5. We're going to go ahead and add that 0.4332 to the left-hand value, that green area of 0.5. And that gives us our answer of 0.9332 as the area between 1.5 and negative infinity underneath that bell-shaped curve. Okay, so that 0.9332, that is the sum of the pink area and the green area. Okay, let's keep moving forward. If I wanted to know what is the area under that curve, or what is the probability that Z is between negative 1.86 and positive 1.86, then in this situation, we're still going to only need to find just one Z value corresponding to 1.86, because remember, this is symmetric. So the table value is going to just give us one of these pink regions, just 1/2 of the total pink region here. Okay, and then we're going to have to double that. All right, so let's go ahead and we're going to switch back to our standard normal table. We're going to find the probability corresponding to a Z value of 1.86, and then we will double that. All right, so we're back to our table. We're going to go down to that row corresponding to 1.8. Okay, and then we're going to go to the column corresponding to 0.06. And you'll notice if we go down that column to the appropriate row, this will give us a probability of 0.4686. And now we want to go ahead and double that, right? In order to find the probability that Z is between negative 1.86 and positive 1.86. So here we are. Okay, we're going to use one table value here to get both of those areas by, again, exploiting the symmetry here. And that gives us a value of 0.9372, okay, which is choice D. Okay, also note in some of these situations, you can utilize a little bit of what you know about your empirical rule to help get rid of some bad answer choices. For example, we know that 1.86 is pretty close to 2 standard deviations away from the mean on either side. And the empirical rule tells us if we go 2 standard deviations away from the mean, okay, then that should contain about 95% of the area underneath the standard normal curve. Okay, and there is definitely an answer choice there, choice C, that looks like it is way off in that assessment here. Okay, let's do a few more examples to make sure we're comfortable with this. Okay, now we want to know something called a tail probability. We're not looking at the probability in the interior of the distribution. We're looking at the probability in the tail, in the upper tail here. Okay, now, what will the table give us? Well, if we plug in a Z value of 1.95 into the table will not give us the pink area here. In fact, if we look carefully at our table, oops, sorry about that. If we go ahead and look carefully at our table, we can see here that the table specifically corresponds to this picture. It's showing us these one-sided values between 0 and Z, but it's not giving us the tail probability. So if we wanted that area in white, we would basically have to take 1/2, which is the area underneath the entire right half of this curve to the right of 0, and we would have to subtract out the blue region. So that's what we're going to do here. Okay, so we need to go find our table value of 1.95 to answer this question. So I'll give you guys a minute to find that value yourself. You can pause the video right now if you want. I'm not going to jump back to the table again here. Okay, but you should see that the table value associated with 1.95 is actually 0.4744. Okay, and if we subtract that from 0.5, which is the area under the entire right half of this curve, okay, then we wind up getting the correct answer here, which corresponds to about 2% probability, a little bit higher, 2.56%, which again is the area in that upper tail. So that makes the correct answer here, choice A. Okay. Again, we could have used a little bit of our knowledge of the empirical rule, right? 1.95 is really close to 2 standard deviations out, which means the amount of area in this upper tail should be about 2.5%, which is very, very close to what we had found. Okay, next question asks us about the probability that Z is between 1.2 and 1.85. Hey, this is going to require us to now find 2 table values. We're going to have to find the table value for 1.85. That'll give us all the area between 0 and 1.85. And then we'll have to subtract out this region here, okay, which is the area between 0 and 1.2. So we're going to find those 2 table values, one for a Z of 1.85, one for a Z of 1.2, and we're going to subtract them. So if you want, jump to your standard normal table, take a moment, you can pause the video, and then I'll reveal the answer. Okay, so solution here. Okay, we're going to take the 1.85 table value, which is 0.4678, and we're going to subtract out the 1.2 table value, which is 0.3849, And the difference between those two areas corresponds to 8.29% probability, which is choice D. Okay, getting the hang of it. Let's try another one. What is the probability that Z is bigger than negative 0.42? Okay, and again, I always recommend for these types of problems, making sure that you are really drawing this diagram. I think it helps not get confused about which areas you're trying to identify. So in this problem, remember, the table value is going to give us this pink region, the area between 0 up to Z. What we're going to have to do then is use the table to get that pink region, and then we're going to add it to the green region, which we know by symmetry has to be equal to 0.5 probability. So take a moment, go to your one-sided standard normal table, and find that Z value, or find the probability that corresponds to that Z value of 0.42. And you can, again, pause the video, and I'll reveal the solution. So we mentioned we're going to take the green region, which was equal to 0.5. We're going to add that to the probability Z is between 0 and 0.42, which is the same by symmetry as the probability that Z is between 0 and negative 0.42. And the table value is 0.1628. We add that to 0.5, and we wind up getting here choice B, which is 0.6628 is the correct answer. In the next problem, let's suppose they asked us for the complementary probability here. What happens if they wanted a Z value, or rather the probability that corresponds to Z being less than negative 0.42? Okay, slightly different problem, but pretty much the same picture. And remember, if this is the complementary probability relative to the previous problem, we can just take 1 minus our answer from the previous part to calculate this. Okay? So the other way we could do that is, again, by using that same table value and subtracting it from 0.5. So either way, we could use the complement of the last answer we had calculated, since we've already done that. Or we can, again, find the table value, which is going to give us this white region, which we calculated last time. And we can subtract it from 1/2, which is the entire left half of that standard normal curve. So take a moment, do that, and you should find that you get a probability of 0.3372, which was the complement of the probability we found in the previous example. All right, moving along. This next question's a little extreme here. It's asking us for the probability that Z is greater than 3.85. And you notice the answer choices are kind of funny here. Okay, they're not exactly precise values. Some of them are. But I think a quick look at that diagram, and again, using what we know about the empirical rule, should tell us that there are some terrible answers here, like choice C. We're not even close to capturing half of the area underneath that curve. But remember what 3.85 Z value means. That means we're almost 4 standard deviations away from the mean. Okay. Remember that 3 standard deviations out on either side captured 99.7% of the area underneath that curve. So only 0.15% was in that upper tail if we were 3 standard deviations out. Now we're almost 4 standard deviations out. So the area in that upper tail has to be extremely, extremely, extremely close to 0. So you may be able to go find that table value, but I think you can use your intuition pretty well in this particular situation. Okay, now we've looked at some examples of using the standard normal table forwards, right? If I give you the Z value, you can give me the probability. But we may also want to be able to utilize this table in reverse. Okay, for example, given that the area to the left of Z is 0.2119, we want to know what is the corresponding Z threshold here. So we're going to go ahead and use the table in reverse. Now remember, okay, this is the probability that we're given, but the table values, those probabilities in the table, that corresponds to this region here in between 0 and that negative z value. Okay, so in order to find the probability in the table and work backwards, we're going to have to subtract the pink region from 0.5, and that will tell us the table value we're looking for here is actually 0.2881. Okay, so at this point, we're going to switch to our table. We're going to find the value that corresponds to 0.2881, and that should give us, if we look to the row and the column, an approximate z value up to 2 decimal places. So if you take a close look here at the table, okay, and we look around this row right here, we can find that value that's real close to 2.2881, and in fact, we find it precisely here. And there it is, 0.2881. And we can now go to the row. We see the z's first decimal value is 0.8, and the z's second decimal value is 0, okay, which means the correct answer here corresponds to a z value of 0.8. However, because we are on the left side of the mean in this situation, okay, because we're on the left side of that mean, it has to be the case that we are dealing not with a positive z value, but with a negative z value here. Okay, so again, draw that picture. It is absolutely helpful in these types of problems. So there are a few more examples in the slides of how to work through the kind of the reverse method of utilizing this z table. We're going to go ahead now and kind of take one step back, starting with our x data, utilizing the z transformation, and seeing how we can use the standard normal table to transform more complicated problems into the same problem that requires only using this one table to do the calculus for us. Okay, so let's go ahead and take a look at this next example. So this question says, suppose x is distributed here with a mean of 8 and a standard deviation of 5. And the question is, given that x is normally distributed with those parameters, what is the probability that x is between 8 and 8.6? Okay, so here's what we know. Okay, we know we are given the mean and the standard deviation, and we're going to have to now convert the two x bounds into z-scores. Okay, so our left x bound was 8, our right x bound was 8.6. And again, first thing I would always recommend doing here is drawing that normal curve for the problem. So this is not the standard normal curve. Note the normal curve here, we're starting off in x space. Okay? And the distribution center to date, we want to know what is the area or the probability between 8 and 8.6. Okay, so in order to make the problem easier, we're going to transform the problem into z space. Okay, using that z transformation we discussed earlier by standardizing the distribution. Okay, so we're going to subtract from each of these thresholds, from the x1 and x2 thresholds, we're going to subtract the mean, and then we're going to divide the result by the standard deviation of 5. Okay, the left x value, you'll notice, is already at the mean. So when we subtract it, we get 0. Then divide by 5, we still get 0. But the x2 value is associated with a slightly larger z-score, as we know it should be from that picture we've drawn here. Okay, so we've transformed our x values into z values. And at this point, we can rewrite the problem. Okay, instead of thinking about the probability that x is between 8 and 8.6, okay, we've now converted from x space into z space. And this probability, due to the nice properties of the normal distribution, is the same under the standard normal curve as the probability that z is between z1 and z2, that z is between 0 and 1.2. So we started the problem here with a normal distribution that wasn't standardized. And what we were able to do is use that z transformation to convert it into a problem where we were dealing with a standardized set of z values. We moved ourselves from the x space here over into the z space. Okay, which means we can solve the problem in Z space, and later on we can convert it back into X space, which we will do in the next video. So we're really asking the following question now. What is the probability Z is between 0 and 0.12? So take a moment. You should be able to go to your standard normal table and recognize that the table value for a Z-score of 0.12 will correspond to the area of that pink region in the right diagram. So here's the approach we took. Okay, we converted the problem. Now we're going to use that standard normal table. Okay, so we're going to go down to the Z row that corresponds to 0.1. We're going to go to the Z column that corresponds to 0.02. And when we do that, we should wind up identifying a probability of 0.0478 corresponding to the area underneath that curve. Okay, so we started in X space, converted to Z space, converted our threshold values using the Z-score, and then we exploited the structure of the standard normal table to calculate that probability, that area. Okay, now let's go through an example where we're calculating a lower tail probability using the table. Okay, this was an interior probability, but we may have an example where we have to calculate a lower tail probability. So let's suppose here that we want instead the probability that X is smaller than 8.6. And again, we can use a little bit of our work from before. We know the Z value that corresponds to 8.6 is 0.12. And we're going to take the same approach. We're going to start off in X space, and we're going to draw the problem. And we're looking for that entire pink area. We want to convert that into Z space. Okay, and we know already the area that we had calculated just in this small region, just in this band from the last example, was the probability Z was between 0 and 0.12. And we're just going to need to add that, okay, by recognizing the equivalence of these two problems to 0.5, which is the entire pink area to the left half of 0, of the center of that distribution. Okay, so all we're going to do here is we're going to take the probability that Z is smaller than 0, which is 1/2. We're going to add that to that table value we found in the last example, which corresponds to the probability that Z was between 0 and 0.12, which gives us a result of 0.5478. Okay, and that is this entire pinkish purplish region there. That pretty much wraps up this segment. We're going to go ahead and look at one more segment in the context of a few different case studies and example problems, and think about how to solve the problem moving from X to Z space, and then reinterpreting our results by moving back from Z into X space if need be. So hope you enjoyed. See you shortly.